We also have what's called arithmetic means. The terms placed between two non-consecutive terms of an arithmetic sequence are called arithmetic means. For example, in the sequence 5, 10, 15, and 20, the numbers 10 and 15 are the means between 5 and 20. In order to determine the arithmetic means between two given terms, it is helpful to think of the two given terms as the first and the last of the sequence. So, if it asks me to place 3 arithmetic means between -4 and 8, then I'm going to say that I'm going to have -4, and then I have 1, 2, 3 terms in there, and then the last term is going to be term 8, or have a value of 8, I should say. Now, when I'm trying to solve for what the change is here, then I can say that if these numbers were side by side, the common difference would equal the later term minus the earlier term. But I can tell that it's not actually going to be, sorry, it should have been minus -4. I can tell that it's not actually going to just be that it go up by 12, because I actually had multiple changes take place in here. To get from T1 all the way up to that 8, I went from T1 to T5. I went up 1, 2, 3, 4 times. Another way I could think of that is that I changed, if this was term value 5, I changed 5 minus, and this was term value 1 times. So I have the common difference is going to be what the difference is between these two divided by how many changes took place. And I have a common difference of 3. When I know that, I can plug the numbers back in. So I have -4 goes to -1, 2, and then 5. And I can always double check to make sure that I'm going up by the same amount every single time, which I am. So if the common difference is equal to Tn minus Tn minus 1, then I can also consider it as the common difference of Ty minus Tx divided by y minus x, or whatever those actual term numbers are. We can also have cases where we can solve when we don't know either the common difference or the starting term. So it gives me a sequence here, and it says that x plus 2 goes to 3x minus 1 goes to 2x plus 1. And it tells me that they form an arithmetic sequence. Well, what do we know about arithmetic sequences? That the difference between term 2 and term 1 has to be the same, because I'm adding the same amount, as the difference between term 3 and term 2. I can use that given the values of these terms. There's term 1, there's term 2, and there's term 3. I'm going to sub them in using brackets because I'm going to be dealing with negatives. And I'm going to say that term 2, which is 3x minus 1, minus term 1, which is x plus 2, has to be the same as term 3, 2x plus 1, minus term 2, 3x minus 1. This is going to give me 3x minus 1 minus x minus 2 is equal to 2x plus 1 minus 3x plus 1. Or, when I combine my like terms on each side, 2x minus 3 is equal to negative x plus 2. I'm going to move my x's over and get 3x. I'm going to move my constant over and state that that's going to be positive 5. And my x value is going to give me 5 over 3. If it wants me to determine the numerical values of each of these terms, then I'm just going to sub in the value of x into each of these terms. So term 1 is going to be 5 over 3 plus 2, or 11 over 3. Term 2 is going to be 3 times 5 over 3 minus 1, which is the same as 4. Term 3 is going to equal 2 times 5 over 3 plus 1, which is the same as 13 over 3. So I know that my sequence is going to be 11 over 3, 4, and 13 over 3. Why does that work? Because 4 is actually the same as 12 over 3. So I went from 11 over 3, 12 over 3, 13 over 3, and I'm adding exactly 1/3 each time. Now, it says the third and eighth term of an arithmetic sequence are 12 and negative 18 respectively. Use an arithmetic means to determine the fifth term of the sequence. So, the first thing I have to do is I need to figure out what the common difference is. My difference is going to equal term 8, which is negative 18, minus term 3, which is 12, all over the n values 8 minus 3. This is going to give me negative 30 over 5, or negative 6. Term 5 would equal term 3 minus 6, and then minus 6 again. Once to get to term 4, and then again to get to term 5. And this would give me 0. Now, how could I use this to find my a value or my first term value. I can choose either of these and put them into my formula to calculate what term 1 was. I can say that if Tn is equal to term 1 minus n minus 1 times my common difference, I can pick any of these sets to do it. I'm going to do it using term 3 is equal to 12. And I can say that 12 is equal to term 1 minus, that was the third term, minus 1 times my common difference. And literally to get my term 1 by itself, I can just move this entire thing to the other side by adding it to both sides. Term 1 is just 12 plus 3 minus 1 times my common difference, which was 6. And term 1, where I started, should have been 24. So I know that my a value, or in our case term 1, is equal to 24. I know my common difference was equal to 6. We're not going to do parts C and D because we didn't list out the values like they sometimes want us to in these books, and it's kind of redundant. We can jump right to, in this case, instead of x and y, they use p and q terms, and we know that d is equal to tq minus tp over q minus p. So if it says the third and eighth term of an arithmetic sequence are this, use a system of linear equations to determine the first and the common difference. If they were doing the simplified form and saying that T8 is equal to T1 plus 7 times D, or negative 18, and T3 is equal to the first term plus 2 times common difference, or 12. All they did was use a system, subtract those two equations from each other. The first term is going to cancel out. 7 minus 2 is going to be 5d, and negative 18 minus 12 is going to give me negative 30, and d is going to equal negative 6. If they know that d is equal to negative 6, they just plugged the value of d back into one of the two equations, basically just like we did. T1 plus 2 times negative 6 is equal to 12. T1 is going to equal 12 minus 2 times negative 6, which is going to be the same as 24. If it wants us to use that to determine the fifth term in the sequence, and typically it's not going to be something as easy as the fifth term in the sequence, I'll probably give you like the 30th term in the sequence, then you're just using those values and plugging it back in to solve for whatever missing term in the sequence it is. So term 5 would equal 24 plus 5 minus 1 times negative 6, which would still just give me 0.